Adapter, often used for the movable end pieces of columns, contains filter flow distributor and possibility to connect tubing. Absorption binding, the process of interaction between the solute, for example a protein, and the stationary phase, a group of methods based on various types of specific affinities between target molecules, for example a protein and a specific ligand, coupled to a chromatography medium. Ligand. Ligand. Back pressure, the pressure drop across a column or a chromatography system. Band broadening, the widening of a zone of solute, for example a protein, when passing through a column or a chromatography system, gives rise to dilution of the solute and reduces resolution, also often called peak broadening or zone broadening. Adsorption, the process of interaction between a solute, for example a protein, and the stationary phase. Binding uh, buffer solution used for equilibration of the column before sampling loading. Binding capacity, the maximum amount of material that can be bound per ml of chromatography medium. The degree of retention of a solute, method that separates proteins on the basis of PL. A graphical presentation of detector responses indicating the concentration of the solutes coming out of the column during the purification. From Greek chroma, the stationary phase, also called resin, the chromatography medium is composed of a porous matrix that is usually fractionalized by coupling of ligands to it. The matrix is in the form of particles, or rarely a single polymer block. Common term for cleaning chromatography columns and or system with the purpose of removing unwanted, non-specifically bound material. Oh, no. Binding capacity, the maximum amount of materials that can be bound per ml of chromatography medium. Capacity factor, the degree of retention of a solute, for example a protein, relative to an unretained peak. Man, chilled. The column, tube, and adapters, all pieces of the column except the chromatography medium, the pack bed. The pressure inside the hardware pressure that is too high can break the column. Column packing, control filling of the column hardware with chromatography medium to obtain a pack bed. The geometrical volume of the column interior, the chromatography bed. Counter ion of opposite charge that interact with an ion exchange chromatography medium after the column equilibration. The counter ion is displaced by a protein that binds to the ion exchanger. If a high concentration of the counter ion is applied, it will compete with the bound protein and elute it from the chromatography column. Counter ligand. The volume outside the packed chromatography bed can be column dead volume or chromatography system dead volume. The dead volume contributes to band broadening, degassing, removal of dissolved air from buffered solutions, elution, release or removal of bound substances from the chromatography medium. Dynamic binding capacity, efficiency, effluent, elution buffer, elution volume, elution time, flow rate, flow through, freight, gel filtration, gradient elution, hydrophobic interaction, hydroxyapatite chromatography, ion exchange chromatography, isocratic elution, ligand density, linear velocity, mass transfer, matrix, mobile phase, peak broadening, peak capacity, peak tailing, pore volume, pressure over the peg bed, recovery resolution, retention volume, retention time, reverse phase, chromatography, sample application, sample loading, sample volume, selectivity, solute, stationary phase, step gradient, elution, void volume, wash buffer, wash volume, yield, and zone broadening. This symbol indicates general advice to improve procedures or recommend action under specific situations. This symbol denotes mandatory advice and gives a warning when special care should be taken. This chapter presents a brief and somewhat narrow description of the history of laboratory scale protein purification. Opinion may differ regarding details of when and how a contribution or breakthrough was made and by whom. The term protein comes from the Greek standing in front. The term was suggested by Johannes Jacob Berzelius in 1838. At the time, there were ongoing discussions about whether proteins were macromolecules or colloidal aggregates, a debate that lasted until 1930. In 1901, Hermann Emil Fischer synthesized a dipeptide demonstrating that amino acids can be linked together, and the following year, Franz Hohmeister suggested that proteins are amino acids linked by peptide bonds. Many years later, crystallized the enzyme urease and showed by chemical analysis that the substance was a protein. This was the first proof that enzymes are proteins. Linus Pauling and coworker proposed in 1951 that the primary structural motifs of protein are A helix and B sheets. In 1957, Christian B. and Simpson and colleagues showed that ribonuclease RNase could be refolded into its native structure and regain its activity after complete unfolding, and reduction is thermodynamically most stable structure with the given amino acid sequence. The same year, Max Puritis and John Kendrew determined the structure of myoglobin. Advances in methodology, protein purification has been developed in parallel with the discovery and further studies of protein. Some of the milestones in the history of protein purification. The selection of milestones might be controversial and is biased towards the content of this handbook. Protein purification has been performed for more than 200 years in 1789 and 24. Oh! From plants that had similar properties to egg white, mainly albumin. Protein purification has been performed for more than 200 years. In 1789, Antoine Fourcroy prepared substances from plants that had similar properties to egg white, mainly albumin. Until the beginning of 20th century, the only available separation technologies were methods such as filtration, precipitation, and crystallization. Repeated crystallization was used by Hofmeister to purify ovalbumin. During World War II, there was an acute need for blood protein. Cohen fractionation of plasma was developed for the purification of albumin and other plasma proteins. The method is based on multiple precipitation steps where pH, ethanol concentration, temperature, and protein concentration is varied for each step. This precipitation method and other, for example, ammonium sulfate precipitation, are still used today. In 1903, the shit. During the next several decades, other important protein separation methods were developed: electrophoresis and affinity chromatography in the 1930s, and ion exchange chromatography in 1940s. Hydroxyapatite, which can be regarded as a mixed mode ion exchange, was developed in 1956 by this guy. Electrophoresis and affinity chromatography in 1930 and ion exchange 1940. Hydroxyapatite, which can be regarded near chromatography media. During the 1950s and 1960s, several new hydrophilic chromatography matrices were invented. The matrices are the solid, often porous materials to which functional group ligands are coupled to obtain a chromatographic medium. Ligand. 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 During the 1950s and 1960s, several new hydrophilic chromatographic matrices were invented. Hydrophilic. The matrices are the solid, often porous material to which functional groups ligands are coupled to obtain a chromatographic medium. In 1955, starch was used to separate proteins based on differences in size. In 1959, Jerker Poreth uh, cross-linked dextran, which was more suitable for this purpose. During the 1960s, other hydrophilic materials for electrophoresis and chromatography were developed. What the fuck? Electrophoresis. 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 Electrophoresis is a technique commonly used in the lab to separate charged molecules like DNA according to size. Gel electrophoresis is a technique commonly used in the laboratory to separate charged molecules like DNA, RNA, and protein according to their size. गांडो जहाँ भी रहो खुश रहो जादू तेरी नजर टू 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 तेरा बदन तू हाँ कर या ना कर तू है मेरी जादू